Good evening. Welcome to the sixth week of the live interaction session for the course Multimodal Urban Transportation Systems. The instructor is Professor Orkopal Goswami from IIT Kharagpur and I am Shankhadeep Pramanik from IIT Kharagpur. Like the previous week, in these sessions, we generally discuss what has been taught in the week 6. We briefly recap those things and then we proceed to some question answers that are useful for solving assignments and for the exam also. So in this week 6 we were already discussing about NMT planning, and first in lecture 26 we have started with different characteristics of NMTs, non-motorized transportation, like for pedestrians or bicyclists, what are different characteristics. These all things we have discussed. Then we proceed to some traffic flow equation, the factors that are affecting the pedestrian speed, that we discussed. Then in next lecture we have discussed about the data collection process and flow characteristics. So data collection process can be different types, like manually we can count the pedestrians, but in recent times with development of technologies we generally do it automatically, or through videography and using of different image based techniques. We generally use this type of data for analyze. And also we have discussed about the flow characteristics. They are you know that in case of the traffic, they are for the vehicular perspective there are different models we generally use, like Greenshield model, Greenberg's model, or Underwood's model. These models are also useful for pedestrian flow for defining the pedestrian flow, and it is quite similar, similar to the vehicular case. And based on that we have discussed several numerical problems. In the next lecture we have discussed about different macroscopic models, and there we have discussed about this single regime and two multiple regime models which are similar to the vehicular flow. And we also discussed about how we should know that whether a model is good fit or not. It is basically based on R square, that we also discussed. Then we discussed about different pedestrian facilities, that we need to design different pedestrian facilities like sidewalk, crosswalk, or footpaths, these facilities, and it will be only possible to design these kind of facilities after knowing that different parameters, like what is the effective width for walking in available to the pedestrian. Then there may be we need to conduct different types of surveys. These things were discussed, and different fundamental flow parameters and of the pedestrian facilities are discussed. Also the pedestrian level of service, which is a version of the vehicular level of service for in case of the pedestrian, that also discussed. And with example we have seen that how different level of service changes from A to F, from best to worst, for different regions like commercial or institutional or recreational center. There may be pedestrian level of service may be different in different context. and we also discussed about how we can determine the level of service for the crosswalk at signalized intersection based on US in highway capacity manual. So with this we have concluded this week 6. Now I shall proceed to the question answers. First is, a person with wheelchairs come under NMT mode of transport. Accept or reject statement. This is obviously accept. For we consider the person will wheelchair under the pedestrian. Next is, what does this A signifies in the following figure? This one, head, shoulder, buffer area or body depth. It is based on pedestrian. So if you, it is basically the top view, and from the top if you consider a pedestrian, this is the head portion, then this is the shoulder portion, and this is the buffer area, that is for the effective for the comfort of the pedestrian. If two pedestrians are very close, then it will be there may be discomfort and faced by pedestrians, so it is basically the buffer area for hand movement and all. So the body width is total from here to here and body depth is here to here. So this A represents the buffer area. Option C will be the correct answer here. Next question. A independent sample t-test was used to test walking speed of two age groups 15 to 20 and 21 to 30. Data is displayed in table 1, also given that for T9 degrees of freedom and for 0.05 it is 2.262, and T value for 9 and 0.1 is 1.833. So select the correct statement from the following option, and this is the table. Here it is for speed of age 15 to 20, and this column is for speed of age to 21 to 30, and these all are given meter per minute. So option A is, both groups do not have significant difference in walking speed at p value 10%. Both groups have significant difference in walking speed p values at 5% and 10%. Both groups do not have significant difference in walking speed at p values 5% and 10%. And last one is, both groups have significant difference in walking speed at p value 5%. So I am giving some time, then I will discuss. So we know that the formula for T statistics is this one. Now we know the x1 and x2 for two groups. So the first step is to calculate the sum of difference x1 minus 2 and the square of difference, that is x1 minus 2 square. So this one is x1 and x2 given. If you do the difference x1 minus 2, then it will come 1, 11, 7, 6, 3 like that. So 70 minus 69, 73 minus 62 like that it will come. And if you again square this one, then it will be x1 minus 2 square. So it will come as 1, 11 square is 121, 7 square is 49 like that. Then you need to calculate the sum of this total column, which will be summation of x1 minus 2, this one, and x1 minus 2 whole square, which will be 381. Now if you see the formula, summation of x1 minus 2, that is 41, divided by number of samples. So there are 10 samples, so it is divided by 10. Then x1 minus 2 square, it is 381, and x1 minus 2 whole square, that is 41 square, and 10, and n is 10 and n minus 1 9. So if you calculate, it will come as 2.665. Now the degrees of freedom is n minus 1, that is 10 minus 1 9. So you need to find the T critical value. For 5% it is given for degrees of freedom 9, and for 0.05 it is given as 2.262, and for 10% level it is given as 1.833. So 2.262, 1.833. Now in the first case, for 5% level, the T statistics value 2.66 is greater than this critical value, so no significant difference between two groups at P 5%, and for 10% also there is no significant difference between two groups at P value 10%. So in both the case there is no difference. So here option C will be the correct answer, that both groups do not have significant difference in walking speed at p value 5% as well as 10%, because in both the case the T statistics value, that is 2.66, is greater than this T critical value. So we put the values as per the formula, then we calculate the T statistics value, then compute it, compare it with the value given for different levels. And it might also happen that without giving these values directly, their charts may be provided, and from there you may have to find the critical value for degrees of freedom 9 and this 5%, that is 0.05. You need to go by the chart and may have to find this 2.262 value, so, and compare it with the statistics to know that whether there is a significant difference or not between two age group or between two samples. So option C will be the correct answer. Next, what advantages and disadvantages does manual counts of pedestrian data collection possess? Advantage is accurate, disadvantage is labor intensive. Option B is advantages can be easily done, disadvantage high accuracy. Option C is advantage is simple and easy to perform, but disadvantage is labor intensive. And fourth one is high quality data free from error, and disadvantage is costly and fragile. So these are the four options. So there are different types of data collection process. Previously, people generally followed the manual counts, but with improvement of the technology, people also use automatic counts or videographic and some image processing techniques. For manual count, it is simple and easy to perform, but the disadvantage is labor intensive. That uh, someone has to stand there for the entire duration of the data collection process. But it is simple because the person has to only see and count the pedestrian. And for automatic counts, the advantage is high quality data and it may be free from error, but sometimes it is very costly, and the device is also very fragile, and there may be instances that the device may be stolen. So for a longer duration of data collection, that is one of the disadvantage. And the costly, it is very costly sometimes. And for videographic survey, more efficient, it is more efficient than manual count, but it sometimes require more skill, and the detection may be sometimes accuracy may not be that high. So in this figure, like you can see that people don't have to count manually, but from the image, videographic image, the mm, processing can be done to count the pedestrians. So in this case, it is asking for manual counts. Manual counts is easy to perform, and the disadvantage is labor intensive. Option C will be the correct answer. What does this K denote in the figure? Pedestrian speed, pedestrian flow rate, pedestrian density, or pedestrian space? So we talked about different flow parameters. Pedestrian speed is the average pedestrian walking speed that can be measured as meter per second or meter per minute. Then pedestrian flow rate is the number of pedestrians passing a point per unit time, like uh, pedestrians per 15 minute or pedestrians per minute, this kind of thing we can do. And pedestrian density is the average number of pedestrians per unit area, and we can denote it as pedestrian per meter square. And pedestrian space is the average area provided for each pedestrian, that is meter square per pedestrian. It is basically the inverse of the density. So in this case, if you consider this one, this K denotes the pedestrian density. Option C will be the correct answer. Next is consider the hypothetical data where density and speed of pedestrians along a footpath are given. Determine the parameters of the flow model using green shield relationship, that is U equal to A plus BK. Use the method of least square. The K value and U values are provided and these are the options. You basically need to find this A and B parameter, this A and B. I'm giving some time, then I will discuss. So you need to calculate this A and B value, and given is this K and U value. So for and you need to follow the green shield model and use the method of least squares. So for B the formula is this one, and A the formula is this one, and this x bar and y bar are the average of x and y. Now we will treat it this K as x and U as y. Now first one, that is xi minus x bar. If you calculate this, it will come first you need to calculate this x bar, that is the average of this column, and y bar, that is average of this column. So it will come 97 and 22.5. Now for xi minus x bar you need to subtract this one from and this one. So 168 minus 97, it will come as 71. Like that for second one, 135 minus 97, so 38. Similarly for these two. And next is yi minus y bar. So y bar you have already calculated and y values are given. So yi is 5 and minus y bar is 22.5, so minus 17.5. These all are with sign. So you have calculated this xi minus x bar and yi minus y bar. Now it is the multiplication of these two. So you need to multiply this column and this column, this 71 into minus 17.5. So we'll get this one. Then in the denominator it is xi minus x bar square. So you can also do this here, that xi minus x bar square, it will come this one. So finally if you put these values like xi minus x bar is this one, then yi minus xi minus x bar multiplied by yi minus y bar is this one, and this xi minus x bar square, which is this one. So it will ultimately you will ultimately get b as minus 0.2, and for a it is y bar minus b into x. So y bar you already know, and x bar also we know, and b value we already got, so it will come as 41.9. Now our equation is u equal to a plus bk, so the a value will be 41.9 and b value will be minus 0.2. So the equation will be like this. So we need to apply this formula to get the b, and after calculating b we can get this a, and we need to put the values in this formula. Next question. In pedestrian flow models, single regime means speed density relation will also be different in different zone of densities. Speed density relation will be also be different in only one zone of densities. Same speed density relationship is valid for the entire range of densities seen in traffic stream. That the same speed density relation is valid for the sum range of densities seen in traffic stream. These are the four options. So while discussing about the macroscopic models, we have discussed about single regime and multiple regime. Single regime is based on the assumption that speed density relationship is valid for the entire range of densities seen in traffic flow, and for multiple regime, speed density relation will be different for different zone of densities, because human behavior will be different for different densities. Like if more people are walking together in a particular space, then what will be the speed compared to that? The speed, if only one person is walking at a particular space, can be more, because like no, can be different actually, because in certain cases if more people are there, so people may not move freely, but in case if there is the density is less, then people can walk freely and the speed can be higher, or the desired speed he can achieve. So there are different multiple regime means there may be more than different uh, in different speed density, in different densities speed may be different, and for the simplest case we generally consider two regime model, where it is separated for congested case and uncongested case. Like in uncongested cases the uh, density is less, and for congested cases the density is more, so the speed obviously will be different. but for single regime the speed density relation is valid for the entire range of densities seen in traffic streams. So option C in this case will be the correct one. Next is consider the following statements and choose the correct option. Pedestrian flow models can be used to forecast future flow parameters using model equations. Option 2 is pedestrian flow models can be used to design the capacity of pedestrian facilities. Which one is the correct one? You need to check. So while discussing about pedestrian flow models and what is the need of such models, we discussed that these models can be useful to forecast the future flow parameters using different relationship between speed, density and flow. Second is to design the capacity of pedestrian facility like sidewalk, crosswalk. These kind of models are very much useful, and also which is linked to the level of service, particularly for pedestrian level of service. These models are very useful, that what will be the speed density at a particular density if the a place is very busy or uh, institutional area, then what will be the speed of the uh, pedestrians, and what are the what should be the width of a particular facility, and whether different staircases or skywalk, these kind of facilities need to be provided or not. These kind of, to understand these kind of things, these models are very useful. So in option 1, pedestrian flow models can be used to forecast future flow parameter using model equation. This is correct. And in the second one, pedestrian flow models can be used to design the capacity of pedestrian facilities. This one is also correct. So option C will be the correct answer. Next is speed density relationship is given 60 minus 10 kp, where now using the above develop the equation showing the relationship between qp and kp. Qp is the unit flow rate, vp is pedestrian speed, and kp is pedestrian density. You can use the relation q equal to kb and calculate. Yes, C will be the correct answer. The relationship is QP equal to KP into VP. So from there you can get VP equal to QP by KP. Now you have this relationship VP equal to 60 minus 10 KP. So you need to put the value of VP in place of VP, that is QP and by KP, equal to 60 minus 10 kp. Now you will get qp equal to 60 kp minus 10 kp square. So option C will be the correct answer. Next is, consider the following graph. What will be its r square value? 1.5 or 0? Yes, C is the correct answer. That r square, that it is the determination that how well the data fits to the actual relationship, and if these are the data points, and in this case the data is actually quite random, and this model which depicted by this equation or this line is not actually fitting the data properly. So here r square is 0 or close to 0, but if the model relationship fits these actual data points perfectly, like in this case, then r square will be 1, and the higher value is indicates more fit. So in this case option C will be the correct answer. Next is, what does the term pedestrian critical gap refers to in terminologies related to pedestrian facilities? Yes, correct answer will be option A. um, Gap, we discussed about different terminologies related to performance. That gap is the time difference between tail of leading vehicle and head of the following vehicle. This one is the gap. Then pedestrian critical gap, that is the minimum gap size in traffic stream which will allow the entry of pedestrian to cross the road, and it is basically a graph between accepted and rejected gap. And we also discussed about pedestrian waiting time, that is time lost between arrival of pedestrian at crossing point and starting of the crossing maneuver. So in this case it is asking for pedestrian critical gap, so it will be minimum gap size in traffic stream which will allow the entry of a pedestrian to cross the road. Next is, determine the critical gap from the following data. The length of the gap is given and the frequency is also given. You may require to draw the graph for this one. So I'll just discuss it. The answer, that from the given dataset we have to calculate the number of accepted gaps and number of rejected gaps by creating their less than or greater than type cumulative frequencies. Like that, length is given, these gaps, length of the gaps are for different seconds are given, 0 to 1 second, 1 to 2 seconds, like that, and frequency is given. So it is basically the number of accepted gaps that pedestrian will cross. If the gap is available this much, then pedestrian will cross. So here we have to calculate the total cumulative, so we need to calculate 0 plus 10 10, 10 plus 20 30, like that we need to calculate. Again, for the rejected gaps also we need to that which gaps pedestrian don't take, so for that we need to calculate in this order, that 66 it is the last one, so 66 plus 54 it is 120, then 120 plus 120 plus 40 160, like that. And then we need to plot these gaps. These are corresponding to different seconds, and these are the accepted gaps and these are the rejected gaps, so number of rejected gaps and number of accepted gaps. So at a where these two intersect, that will be the critical gap. So in this case it is 5.7. So option C will be the correct answer. Next is, according to the observation made in Indo-HCM, crossing speed increases with increase in the number of lanes. Okay, so these are the frequencies and we got the number of accepted gaps. So for 0 it is 0 here, for 1 it will be 10, like here just this one. For you can take for 0 to 1 you can take the mid value, maybe 0.5, or for 1 to 2 you can take the value of 1, like that. Maybe the graphs are not plotted as per the scales, but in x-axis it will be length, like seconds, in seconds, like 0 1 2 3, these mid values. And in y-axis it will be number of accepted gaps, like 0 10 30 60. So you can see that there is a increasing trend. Like if we plot for 0 it is 0, then it may be for 1 if you consider 10, then for 2 it is 30, so this may be here. Then for 2 to 3 if you take the midpoint, that will be 60, then 100, then 150, 220. So it is a quite a increasing trend. And if you consider this number of rejected gaps, for 0 it is 220, so it is quite high, above 200. Then for 0 to 1 it is also 220. If you take the mid value, like if I can open the Excel, these are the mid values. These are the mid values, and the accepted gap if you plot 0 10 30 50. So you can see that there is a increasing trend, and similarly if you plot the values, you take the length of the midpoint of the length of the gap and take the number of rejected gap, then it will be downward trend, uh, and the intersection point of that will be this one, and roughly it will be 5.7. So in this case it it is between 5 and 6, and 5 and 6 only this 5.7 value is there, so you can take this value as 5.7. So you need to take this mid value of the 0 to 1, and then you need to plot it against these accepted gaps and these rejected gaps. So, and if you plot it for the rejected gaps, you can see that it is similar to this graph, that one is increasing trend, that is the accepted gaps, as the time is increasing, like maybe a person is not accepting a gap of 2 seconds between two vehicles, and but many more people will accept a gap of 6 seconds or 7 seconds, so it is increase in a increasing trend. And if he is not accepting a gap of 1 second, that means he is rejecting it, so the rejection value is in a decreasing trend, and the intersection value will be the critical gap, this one, which will be between 4 to 5. So through that you can calculate this 5.7. I hope it's clear. So moving to the next question, according to the observation made in Indo HCM, crossing speed increases with the increase in the number of lanes. Accept or reject? Okay. Yes, it is correct. Crossing speed is increases with increasing number of lanes. Next is calculate the effective width available for walking along a pedestrian facility considering the shy distance is 0.6 meter in both sides and total facility width is 3.5 meter. Correct. C will be the correct answer. So um, here we discussed about that this is the total walkway width from curb to this edge line, and there is shy distance because people may not want to go at the edge or at the exactly at the curb, so people generally walk after a certain distance. This is actually termed as shy distance, and the effective width is available width after subtracting this shy distance. So effective width in this case is saying that total facility width is 3.5 meter, and in both sides shy distance is considered as 0.6. So 2 into 0.6 will be deducted from this total walkway width, that is this portion and this portion, so it will come as 2.3 meter. So option C is correct. Next is a 5 meter wide footpath in an commercial area is barricaded with guardrail on both sides. The existing peak flow rate is 1200 pedestrians per 15 minutes. What will be the pedestrian level of service? Use Indo-HCM, PLOS and shy distance definition, and the table is given for the shy distance. And here it is saying for commercial area barricaded with guardrail. So guardrail, this one, so the shy distance value can be taken from 0.4 to 0.6, so we can take a middle value of 0.5 of shy distance. And this table is given for calculation. Yes, C will be the correct answer. So we need to use this table for the to calculate the PLOS for 20 pedestrians per minute. Yes, right. So this table will be used, and it is what in what sense the values are given, that pedestrian per minute per meter. Now it is given for the commercial area. We are in the question it is asking for commercial area, so we'll see only this one. And now we need to calculate the peak hour flow rate, that is in pedestrian per minute per meter, in which the values are given. So for pedestrians, for the effective for that first step will be to calculate the effective width of the footpath, that is total width given 5 meter width of the footpath, and the shy distance we can get from this table, and if we consider it as 0.5 for both the side, so 0.5 into 2, so it will come as 4 meter. Now pedestrian flow is given 1200 per 15 minute, that is 80 per minute. So 80 pedestrian per minute. Up to this one we have done. Now pedestrian flow rate, that is the pedestrian flow rate divided by the effective width, that is 80 per minute, that is we have got, and 4 is the effective width. So this total one, pedestrian per minute per meter, so it will come 20. Now we need to find for the commercial case where is 20 lie between 19 to 30, so it will be of level of C, level of service C. So option C will be the correct answer here. Next is Calculate the PLOS of pedestrian crossings at both major and minor streets of a signalized intersection operating with 100-second cycle length and no pedestrian signals. Major street For the major street, phase green time is 48 second and crosswalk length is 18 meter, and for minor street the crosswalk length is 12 meter and phase green time is 33 second. So for both the road you need to calculate the pedestrian level of service for crossing, and the formula will be used 0.5 c, that is the cycle length, minus the green time for the corresponding case, divided by the c. In the lecture there may be given as 2 here, but it will this 2 will not come here. There are some mistake in the lectures, but these 2 will not come. This will be the formula. Okay, minor PLS is if, just let me calculate. So this is the formula 0.5 into c minus g mean by c. Are you taking G for the major street? It will be like, if we open the actually the formula will be a bit different in this lecture. The formula will be formulas are given different. So for the major street we need to consider this G mean, and for that here it the cycle length is saying that 100 seconds, and they are, suppose here is a minor road meeting a major road. So green time for the major road is 48 second, and crosswalk length is 18 meter. This one is 18 meter, and for minor street the crosswalk is 12 meter, and G mean, that is green time for minor road, is 33 second. And here calculate the pedestrian level of service for crossing both major road and minor road of a signalized intersection. Now for a major road, calculate the crossing, and also it is saying that no pedestrian signals are given. So when there is a green signal in the major road, that time vehicles will cross, so pedestrian cannot cross. But when this signal is red, then pedestrian will cross. So this for green time for pedestrian, actually for the major road will be the green time for minor road. In that time people will cross the road, but here it is actually given for the pedestrian crossing. For the major street, phase green time is given 48 seconds. That is for the car or truck which are going in the major road, for that 48 seconds is the green time. So in that time vehicle will move. So in that time, if anyone wants to cross from here to here, they cannot cross. But when they will cross, when there is a green time for the minor road, that is in this 33 second, there will be no movement in major road. So in that time they can cross this major road, that is in this 33 second. So for pedestrian delay for major street will be they will cross in this G mean, that is this 33 second, and the cycle length will be 100. But I think this formula, I think there is some problem with the formula. I will check this one and again post it in the discussion forum.
Good afternoon. Good evening, sir.
Yes. Hello.
Yes. Are you getting me?
Yes.
Okay. So for what you are saying, if we are calculating the pedestrians delay for the major street, we will use G minor for the minor street, right?
Actually, in the lectures, the formula is different, and in this one, uh, just a minute, average pedestrian. Actually, in this case, for the assignment or previous question, the formula is different, and the assignment in the lecture, the formula given was different. So I will check this formula again with the highway capacity manual, and I will then post it in the discussion forum. So there might be some mistake in this formula given here, so we'll check that, and we'll provide it in the discussion forum. So next question is, speed density relationship is given as Vp equal to 60 minus Kp. Now using this, develop the equation showing for relationship between QP and VP. In last case it was QP and I guess in with KP, but in this case it is for QP and VP. Yes, sure, it will be before Wednesday. Yes, option A will be the correct answer. So similar to this equation, QP equal to KP VP, we just need to get this VP, and if we provide it in this equation, the equation given VP equal to 60 minus 10 KP, then we can get QP equal to 60 KP minus 10 KP square. Now if we subsequently for QP and VP, if we use this KP equal to QP by VP, so from here then we can get QP equal to 60 VP minus VP square by 10. So option A will be the correct answer. So these are the answers, and that's all for this week. I will again check this question and post it in the discussion forum, or the updated PPT in the drive will update this one. So that's all. Thank you. We'll again meet on next Monday. Number 6. Okay. This one. Okay, so here actually density and speeds are given, and the green shield model is u equal to a plus bk. Now the determine the parameters means you need to determine this a and b. These are the parameters using the k and u. Now this k, for calculating this, the equation is for b, it is xi minus x bar multiplied by yi minus y bar divided by xi minus x bar square. So if we consider k as x and u as y, so for that xi minus x bar, yi minus y bar, we need first we need to calculate this x bar, that is the average of all of this, that is this for average of this one, and we also need to calculate the average of these four, that will be y bar. So for xi yy it will be xi is 97 minus xi is actually 168, so 168 minus 97. Similarly it will come as 71. Similarly for the next one it will be 135 minus 97, so it will come as 38. Similarly for this one and this one also. And for yi minus y bar, yi is 5 and y bar is 22.5, so 5 minus 22.5, which will be minus 17.5. Now for the numerator part, we need to multiply this one, 71 into minus 17.5, so it will come as this one. Similarly, if you multiply these two, it will second, third and fourth will come, and finally if you sum these four, then you will get 2865 minus 2865. And in the denominator part, it is xi minus x bar square. Xi minus x bar, we have already got this 71. Now it is the square of that, so 5041. Similarly for 38 square, 72 square, and after that you need to sum all these four to get the summation. Now if you calculate the b, the numerator is minus checking 2865 divided by, yes, then it will be this 2865 divided by 13038. These two, this one is the denominator and this one is the numerator. So if you divide these two, it will come as minus 0.2, minus 0.2. Now for a, it will be y bar minus b into x bar. So y bar we already know it is 22.5, minus b into x bar is b is minus 0.2 and x bar is 97. So it will be 22.5 minus b is 0.2 into x bar is 97. So it will come as 41.9. So we have for this equation we have got this a, which is 41.9, and b, it is 0.2. So through that we can develop this equation. Okay. Is there any doubt in any other question, or should I repeat any other question? Okay, which this one for
Uh,
this
yes,
question?
yes. For I asked, I think, three questions, three different questions regarding different calculations within the notes. But this was one of the questions because in the slides, they, so can you please go back to the question for this answer?
Yes.
Okay. Okay, so for this question, um, for the note question, they had that K is equal to the density and U is equal to the speed. But also we had the equation Y equal AX plus B. So I don't know if we are ignoring that equation and just using this.
In the lecture notes, like in
Yes, lecture notes.
um, uh, can you tell in which?
Page. Numerical problem one. I think it's
Yes,
numerical problem.
this one.
Yes, sir. So for this, we were told that Y is equal to AX plus B, and X is the speed and Y equal density.
Yes,
Then follow down, we say X like Y equal AX plus B, X equals speed, and we know speed is equal to U.
yes,
Then Y equals density and is equal to K. But the second, like before the question, before the answer, yes, before the answer, yes, before the answer, they said that since U equal under the table, since U is dependent, no, just down, no, down, it's next step, next, okay. Since the speed U is dependent on K, then X equal K. I didn't get that part because first we say X is equal to U, then now we are saying X equal K. First X is equal to speed, but now they are saying X equal density because it's dependent on the density. I don't understand.
okay. This, this one actually, this one is correct. Don't consider this one. That U is the Y and X is the K, and consider this one, and with that you can proceed for the answer, like calculating. U is the Y and X is the K. uh, Maybe some mistake is there. I will check with the instructor, and but for the time being consider this one. Mm. So I guess since this green shield equation is V equal to Vf minus Vf Kj into K, so it is better to consider this one, that in the speed will we will consider the left hand side, that is in place of maybe V, uh, that is the speed, we may consider this one, that is y, and for the density we can assume it as x. So for the time being we can consider this, but I will again check with the instructor and the team whether this is given correctly or not. 5 assignment 5. Okay. Okay, this one I will also check week 5 assignment. Okay, if in the week 5 if there is any problem in the assignment, then the team will later replace it with the correct answer, and maybe the marks also will be updated. Yes, it is.
Another thing, can can you attempt assignments and submit them multiple times?
Sorry. Hello.
Yes, hello, sir.
Yes. What you are saying, that SMS?
I was asking if you can submit assignments multiple times. Like I did maybe like two or three questions and I submit in out. do again and submit afterwards?
I am not sure of that, but before time, I think there maybe it may be permitted that the answer you can change the answer, but also I am not sure about that whether that can be changed. But I think the answer may be changed before the due date.
Yes, that's what I'm asking. If the answer can be changed before the due date.
Mm, uh, that I am not sure. Just I am checking. Yes, I think you can change the assignment multiple times. I am not sure, but you can just drop this query in the Q and A portion, and they may uh, mm, mm, will provide a better answer. But I think you may change the answer before the due date multiple times. Like as I am seeing that I have just submit one assignment, then I can uh, give the answers and again I can submit. So this may be possible. Okay, hello. Here it is written that you may submit any number of times before due date. The final submission will be considered for grading. It is written just above the submit answer button in the quiz. this one. Okay, here you need to calculate the this x1 minus 2, that is 70, minus this x2 value, that is 69. So it will come as 111, similar this, and then you have to add all these values. It will come as 41, and you need to square each of the values, like 1 square is 1. And is it not visible?
Oh, just the answer page is visible. Just the last answer page. The
Okay,
last page on the website.
okay, just a minute. This one. Now this is the formula, and uh,
Now your page is not still visible.
okay, I'm sharing it again, just a minute. Is it now visible?
No.
Okay. Is it showing the blank screen?
Yes, just a blank screen.
I think it should be visible now. Can you join again? Like I think it is visible from my side, but maybe some due to some issues it is not showing. You can just rejoin, then it might be helpful. Is it now visible? Is it now visible?
Yes, it's okay. It's okay. Thank
Uh, okay. We have to, in this question, uh, for doing the independent t-test, we need to calculate the t statistics, which for which we need to follow this formula, where x1 minus 2 is this one, x1 minus x2, basically that is 70 minus 69, 1, 11, 7, like that. And ultimately if we add all of this, so we'll get 41. Now if we again again need to square this x1 minus 2 square, so x1 minus x2, that is 70 minus 69, that square, so 1. Similarly for 11 square it is 121, 7 square it is 49. So if we add all this, then we will get 381. Now if we put this value, that x1 minus x2 summation, that will be 41 divided by the number of sample, that is 10, then x1 minus x2 square, that is 381, again this will be this x1 minus 2 square, so it will be 41 square just, then 10, and n into n minus 1, that is n into n minus 1, that is 10 into 9, so it will come as 2.665. Now we know the degree of freedom is 10 minus 1, 9, and it will required for the calculation of the critical value. So we have already provided with the critical value, that is this one for 5% confidence level and this one for 10% confidence level. Now our t statistics value is 2.665, which is greater than the these value for 5% value as well as for the 10% value. So we can say that there is no significant difference between two groups at 5% or 10% level. But if there are if it is less than t critical value, then we can say that there will be difference between two groups for 5% as well as for 10% level. So we need to calculate like that. So we need to calculate this t statistics and we need to compare it. Okay. Uh, are you still there? Just for this question, that calculate the PLOS of pedestrian, uh, there was a confusion for this formula. So as I am seeing this, uh, this one highway capacity manual, so here the formula is like this one, that here they have represented it QTDO equal to NDO C minus G square divided by 2C. So Q is the total time spent by the pedestrian waiting to cross the major street during one cycle. So he has to cross the major street, and uh, this C is the cycle time, and G is the effective walking time for the phase serving for the minor street through movement. That is basically the green time, that minor phase through serving minor street through movement is basically the green time. So effective walk time, that is G walk mi. So that is basically this G for minor road. So for the formula you need to calculate it like that: zero point 0.5 into C minus G for the minor road, but remember it is for the pedestrian delay for the major street, means total cycle length is maybe 80 seconds, and for that for or it is 100, as we can see here. Just a minute, that here in this question we have told that the 100 second is the total time, total cycle length. Now among that, for major road there is a green time of 48 second, and for minor road the green time is 33 second. So you can understand that the pedestrian can only cross the major road when there is no vehicle in the major road. So 0 0.5 into total the signal length, that is C, is 100 second, and minus G of the minor road, that is 33 second, that is 33 second given. So it is basically that time they have to stand there and wait for the signal. So it will ultimately come as 22.44, which will correspond to level of service C. If you see this is actually the formula I have shown in the highway capacity manual. Also have this formula, that C minus G divided by 2C. So average pedestrian delay is equal to cycle length minus effective walking time for phase serving the minor street through movement, that is the actually green time for the minor road. So total cycle length minus green time for the minor road, and D is the average pedestrian delay. So C minus G divided by C, and in highway capacity manual you can see similarly, just here it is 0.5, but here it is represented by 2C, but both the things are similar. So if you calculate corresponding to that, it will 0.5 c minus g by c, so 0.5 100 minus 33 by 100, it is for the major road. Similarly, if you calculate it for the minor street, so it will come as 100 minus 48, which is for major street, g for major street, divided by 100, so it will be around 13.52 second. So ultimately it will be level of service of b, and fast major road is for level of service c. So this will be the answer actually. There may be some problem uh, with the study material, um, but it will be the answer. This one will be much more. Okay, I will send it. although it is 2010, but I think the similar formula um, is given in 2000 also. So yes, it is. You could have downloaded it from Google also. So is there any other question, or otherwise we can close it? Okay, thank you.